Hello and welcome to a concept review module on color use for cartographic visualizations. It's both the art and science. My name is Ann Johnson, and if you have any suggestions, please do contact me. It's brought to you through a National Science Foundation to the Geotech Center. This module will review the effective use of color for geospatial visualizations. It will briefly look at the science of how we perceive color and how different media can display it. We will also look at how art and cultural perspective influences the interpretation of colors used for geospatial data visualizations. We will conclude with a review of how physical visual deficiencies can affect the use of color for geospatial applications. Let's briefly explore the science behind how the eye sees colors. The electromagnetic energy from the sun can be reflected from objects it strikes. The human eye can then collect or sense that energy from a narrow portion of the visual part of the electromagnetic spectrum and collects it within the eye structure of rods and cones. Based on the wavelength of that energy, the brain interprets as a color. This is a simple explanation, and more details about what it really means to see can be found in the TED lecture on How We See Color video link on this slide. This slide looks at the dimensionality of color. Hue is often used interchangeably for color, and it's really the basic or pure color without any kind of modification. Intensity or value is the lightness or brightness of color. And saturation is the level of neutral gray in a hue. So it's less gray is more saturated or more a pure color. True primary colors, there are two groups. One is additive and one is subtractive. And we're going to talk about those additive primaries and subtractive primaries and how they're used. An additive primary color is associated with emitted light. So here again, we're looking at that Roy G. Biv RGB color model. And then with equal values of R and G and B wavelengths, it appears white. So here is the three primaries of additive, red, green, and blue, and you can see how they can be combined to show other colors or white. Subtractive primary colors are generally associated with a printed ink, and we call those colors cyan, magenta, and yellow. When all three of them have a value of 0, then it appears as white. Numeric values are derived for these different colors on a portion of around a central or neural point on a color wheel, or on an axis on a color space coordinate diagram. The link below goes more into this diagram, but here we can see that the color values we're going to be talking about go from 0 to 360. So here are two examples of using those numbers, numeric values, for either additive or subtractive primary colors. Using the additive primary colors for RGB color model, it's usually used on a computer model or an LCD projector, and it's very interesting how often your computer monitor and a LCD projector will be quite different, even though you use the same numbers. For the subtractive one, the values, and this particular one is the CMYK color model. It's also on a color printer or plotter or on lithographic press. These are just two examples from ArcMap software of dialog boxes that allow you to set those values, and other software may use other models. Quantitative color conventions, we're going to look at how we looked at colors and how we determine really what kind of colors and color ramps we should use. And we're going to look at different data sets and really look at what the data is telling us. So unipolar data, bipolar data, or balanced data. Colors then used for these chosen schemes should also take into consideration the meaning of the colors for the intended audience. So first we're going to look at how they are classified and distributed, either uni, bi, or balanced, and then think about the color meaning. Unipolar data have no dividing point or complementary parts, and a sequential color scheme are often very good, appropriate for this. And here we have a sequential color scheme of light yellow, green, dark green, all the way to dark blue, and the proportion of not graduating from high schools in 2011 are shown, with the highest values being in the darker blues, with the least values in the greens and yellows. Here are two examples from Bipolar. So on the right is a graphic legend from job gains and losses. So the red colors indicate around a 0 to increasing job gains, and in blue colors, increasing job losses. On the left is a graphic of the world and looking at the close of stock at the end of stock market day to see whether stocks in those countries have gained or lost since the last close. Balanced data just shows that there are two different classifications of owners and renters here, and one is showing those that are predominantly owners in the blues and those that are predominantly renters in the reds. So it's just the ratio of owners to renters. Qualitative color conventions, it's really matching those colors to the feature or type of theme of the feature it represents. So now there is some issues here with people with color deficiencies, but really the simple meaning for a color is usually like water. Water should be blue, of some color, blue. Forest should be green. Hot usually red, and cold blue. Sometimes for important or bad things it may be red, but this is very variable. And it's really not so simple meaning of color either, because there are many, many different cultural differences that can depend on the geography of the region, different countries, ethnicity, religion, age, gender. They can all influence how a person perceives the different color schemes. So a cartographer really has to consider those factors when selecting colors for different features and data visualizations for a specific audience. Remember too about color deficiency issues for some people and what that may look like for them, and we're going to talk about that at the end of this PowerPoint. Psychological reasons. There are some things too, just truly psychological. You know, people react to different colors in a response, and there's no set way you can predict how they're going to react. Here's a nice map. It is, you know, not anything medium monthly rent in dollars, but it may make you feel uncomfortable because it may equate with something where you see red and it makes you feel very uncomfortable. So sometimes this color is not a good thing. Here, the quality of the color conventions. Cayenne for water is good, and it looks pretty good on printed maps, but not so good on your monitor. So if you're going to do a presentation, you may think about that. Yellows and tans for arid regions, green for heavily vegetated regions. These are kind of things that are just conventions that most people will feel aligned with. Here is the example of red for hot features and blue for cold features, and here are the little symbols on the left are red fire symbols, and you can think of those as fires. Of course, in Alaska you can think of cold, so the blue is cold. So we also have feelings for colors, the different colored bands, you know, we're warm colors and cold colors. This is a theme-oriented color scheme. So the theme is green technology, and so it's showing things in green. Different ones would have different possible colored schemes. One is wines, red wines. Maybe they should be all in reds. We often see the Democrats and Republicans as blues and reds. Also, you can consider the map's mood as far as, if you have something going on like car bombs or something, probably it's going to be reds. And for some of the more historic looking maps, may go with grays. This is one where color match to the theme is probably appropriate. This bright pink palette for a Barbie doll is probably very good, but I would suggest that for most other maps it would not be appropriate. Some other things to take note about when choosing colors, again, that warm color or cool color. Cyan has a color temperature higher than the red because it's higher in energy, but people really feel that those colors are warmth where the other colors represent coolness. For qualitative categories, we suggest using distinctly different hues or different colors. So it's a non-sequential hues, and they really represent totally different qualitative categories. And these are colors taken from the National Land Cover Data Set, and it's often good. There are ones for different industries that are kind of standard. Monochromatic or one color schemes and colored ramps with the same hue and color values from low to high or high to low. The more light colors of a hue than dark shades and monochromatic scales are important. The human eye can better differentiate among those light shades than the dark shades. So, also contextual reasons. The background color of whatever you're doing will affect how the colors look. So here we give two examples of grays on a black background and a gray on a white background, and they appear very different. The gray on the left appears much lighter than the gray on the right. And on color, on blue or green, the grays on the left may appear greenish or reddish, and the gray on the right appear yellowish. High color value or darker color is perceived as more important. So always think of that when you're doing something. What is most important, and the dark color should be probably that color ramp. If you need more help in selecting colors, I suggest trying a look at Color Brewer applications. Color Brewer was developed by Cindy Brewer from Penn State University, and she has many examples, and there's books that she's also authored. But Color Brewer app for details, take a look at this link. And some of the things that you can see on this link, here's some examples from that Color Brewer website and application. And just looking at different color schemes, different uses of maps, good and bad, and really looking at how you should be colorizing your maps. There are also physical reasons I've mentioned earlier. Different people see colors differently, and there's very different visual processing systems varying from person to person. Visual impairments complicate the choice of colors, and there's a really good video that was created by IGET, Integrated Geospatial Education, Technology and Training, National Science Foundation grant on color deficiencies in cartography. And if you look at this, it will give you some good hints on things you should and shouldn't do. For additional help on that, Color Brewer also has on her website this application that can help you look at different visualizations and colors. She uses also and goes to Color Oracle, and it's an add-in that simulates color blindness, and it can be very instructive if you created a map and then look at it for someone with color deficiencies. I just want to thank Hugh Howard from American River College for allowing us to use his Cartographic for design for GIS program and images. Thank you. There are additional concept review modules from the Geotech Center website. Also, there are model courses that if you need more in-depth explanations. My name is Ann Johnson. If you have any suggestions, please do contact me.